So we have completed the preferred ring-based routing for PDRS and PSRS. So we found that PDRS is kind of same as PIRS as shown in figure 1, and what we can found is PSRS is same as PORS scheme that is shown in figure 2. So let us move towards the concluding section of this part. It says that load adaptive routing for throughput enhancement and load balancing. So far we had been only talking about load balancing. That is, we were always avoiding the central ring or ring 1 so that there should not be any kind of void formation or ring kind of network formation within the uh, within the hybrid wireless network. Okay, so there is something called as throughput enhancement, that how output can be enhanced by the scheme. So for that, what all things are being done is explained here. So it is said that a measure of load balancing is traffic fairness, and this can be achieved for every node in the network when the number of packets relayed by a particular node is proportional to the originated traffic. That means for a network we want two things. First one is traffic fairness. That means all the nodes, sender nodes, should get chance to transmit the packets from the sender to the receiver, and load balancing should occur. That is, all the nodes within the network should get equal chance to carry the packet from the sender to the receiver. So as the number of packets increases, in that case the load on particular node or particular link, it keeps on increasing. However, defining traffic fairness as above, that means PIRS and PORS, may not lead to an efficient utilization of network resources. So whenever we are using inner ring or outer ring kind of a thing, maybe we are trying to save the central part, that is the ring 1 of the network, but by doing this PIRS and PORS, we might not be able to achieve best output. That is, huge or fast data transmission might not be achieved by PIRS or PORS. So every positive thing might be having some flip side. That is, we are achieving the load balancing through PIRS and PORS, but the output increment or throughput enhancement might not be achieved by PIRS or PORS. So hence traffic fairness is defined at some literature from a load balancing point of view. So these two things, if found together, is the best condition. That is traffic fairness, throughput enhancement, and load balancing. All these three things, if we can achieve, that is the best case. So it is said that hence traffic fairness is defined at some literature from a load balancing point of view. So the fairness index C. Okay, so there is little bit of equations involved in this. So fairness index is defined by C. It is a ratio of maximum relay load experienced by any node in the network. So ratio of the maximum relay load to the average relay load over the entire network. So at a certain time, maximum load is carried by a network, and after certain time the load will become less. Okay, so throughout any network or any link or any node, they are not carrying maximum data. So there are two things: one is maximum relay load and another is average relay load over the entire network. Ratio of these two is called as fairness index, and it is ideal if this is equal to 1. Okay, if maximum load is equal to average load, then in that case we can say that the maximum load is comparatively moderate, or the node is actually having a uh, perfect balance or perfect fairness. Okay? So ideally, when the load is uniform across all nodes, in that case the fairness index is equal to 1. So that is what I told you: if maximum load is equal to average load, then the fairness index is equal to 1, and that is the best scenario. The lower the value of the fairness index of the network, the better the load distribution, and hence traffic fairness. So maximum load should be less than average load. If that is the case, sir, if maximum load is less than the average load, then it is far better. Okay, in that case we are not exhausting any node batteries or anything. Okay, so one is the case that is the best case that can happen, but lower the value of the fairness index, that means lower the value of C, that means if maximum load is less than the average load, nothing better than that. Okay, so no part of the network is getting stressed. Though the standard deviation of the relay traffic would be a good measure of the load distribution, it may not provide a true account of the traffic fairness achieved by the mobile node. So, standard deviation means variation from the average. Okay, so if the standard deviation, it should be less. Okay, that means it is the best scenario if the network is always carrying the average traffic or less than the average traffic. Okay? So there is no point finding the deviation from the average traffic or deviation from the standard deviation. But this standard deviation might not give us the true picture of the network load all the time. Okay. It is because some nodes may be loaded more lightly and some nodes may be loaded very heavily. So instead of finding node by node load on the of the network, it is better we find the average overall network load. Okay, so that will be better. So for achieving fairness, reduction of the relay traffic at the most stressed node, the node which experiences the maximum unfairness, is essential. So this happens every time. So if there is a group, there are four people who are working in the group, one person is getting unnecessarily overloaded. Okay, so how can we make the group working better? If we just share the overburden or extra burden on one person equally among the other three, in that case we can say that the load balancing is occurring. The same thing here. For achieving fairness, reduction of the relay traffic at the most stressed node, that means whichever person is working with the highest burden, okay, his load, if we are trying to average out or equally distribute among the others, in that case the best fairness can be achieved. So fairness of load in this case is being discussed. Since all the other nodes relay less traffic as compared to this node, minimizing the fairness index will improve the overall fairness of the network. So in this case, what is being in this slide, actually what is being explained is how can we normalize or how can we average out the overall load of the network among all the nodes. Okay, so we have to just check what is the total number of data packets to be transmitted from the source to the receiver and how many nodes are there. So total number of packet to be transmitted, exactly if it is equally divided among all the nodes in the network, that is the best scenario. Okay, and that is the best fair case of load distribution. And in that case, that will make all the nodes equally exhausted. So there will not be one or two nodes which will be exhausted more and their battery will be exhausted and the node will be dead. So this kind of thing will be avoided in this case. So this is the same discussion what we have done in the previous chapter also. In this module also we have discussed the same, that is quality of service and load balancing and all these things. So the gist of that is given here. And one new term we are getting here is fairness index. So this can be asked in the short note or this can be asked in a short question. So what is fairness index? Is a ratio of the maximum relay load divided by the average relay load over the entire network. So maximum load by average load of the whole network is given by fairness index, and the fairness index is 1 is good case and lower the fairness index, that is the best. Okay, so fairness index value C, lesser is better. Then in this load adaptive routing, so this is a kind of a literature survey kind of a thing. So two papers we are discussing. The first one is Hasanain and Zhao. Okay, they had proposed a novel protocol called load balanced ad hoc routing (LBAR) protocol. So load balancing ad hoc routing protocol, it defines a new metric called the degree of nodal activity. Okay, so how much activity is taking care at every node. Okay, so that is a new metric or new parameter that was defined by Hasanain and Zhao. Okay, so they were representing the load on a mobile node by measuring nodal activity for every node. So the main objective of this scheme is to find a route between the source and the destination such that the end-to-end delay is minimum. Okay, so previous case it was maximum relay load divided by average relay load. In this case, Hassanan and Zhao, they are finding the load balancing or the parameter for load balancing is different. In this case, they're trying to find out between source and destination node the path where the end-to-end delay is minimum. Okay, that means the transmission delay should be minimum. So this is kind of a Dijkstra algorithm. This is kind of a lowest distance algorithm. So this idea behind minimizing the delay is based on the fact that a path through a less congested region does not get delayed due to the contention for by the channel of intermediate nodes. So this is doing what? So while they're trying to find out a less delay path, they're doing what? So one path which is used by all. So one road which is used by all, that path gets congested. And if we are also trying to send our data through the same path, again our data will get congested. So instead, what you do is you reroute. Maybe you will be passing the data through a longer path, so it might not be a shortest path, it might be a longer path, but which is avoided by all because everybody is trying to go through the shorter path. So in this case, what Hasanan and Zhao they are proposing that you take a longer path between the source to destination, which will avoid the maximum rush. Okay, which will avoid the path where rush is maximum. So in this case, by finding a reroute or by finding a maybe a longer path, what's happening is though we are taking a longer path, but traffic in that path is less. In that case, delay between transmitter and receiver will be less. So the idea behind minimizing the delay is based on the fact that path through a less congested region. Okay, because not many people will be taking the longer path, so it will be less congested. It does not get delayed due to the contention the channel by intermediate nodes. So whenever it's a shorter path, everybody will try to go by that path. Contention is more, congestion will happen, delay will happen. But if there is a longer path, in that case not many contention will happen in that path because it's a longer path. So everybody will try to avoid that path. In that case, delay will be less. So this is a much more of a strategic decision which is taken. A setup message is sent by the source in order to locate such a path, then which is though longer, but the transmission time or data sending and receiving time through that will be less because congestion is less. So a setup message is sent by the source in order to locate such a path, and the destination responds with the acknowledgement containing the selected path. However, fairness of LBR becomes a secondary objective. So in this case, we are not checking whether it's a fair transmission or not, because in this case the length of the path is becoming a little more. Okay, but the main aim is the delay has to be minimized. So for LBAR, which is proposed by Hassanan and Zhao, the main defining parameter is delay. Okay, so the delay should be less. So this is another way of throughput enhancement and load balancing. Another paper was discussed by Zhang et al., and they might have proposed something new. Let us check. Okay, so they have proposed a multi-path routing scheme and analyzed the effect of distribution of load among multiple paths using a queuing model that incorporates the traffic among this path. So I told you initially of this chapter that if there are 5 paths from the source to destination, you define 20% of the load to every path instead of selecting the shortest path and transmitting all the 100% load through that. Okay, so instead of overburdening one single path, what you do is distribute the number of packets equally among all the paths. So from source to destination, if there are 5 paths, what you do is you divide the total load 100 packets. So through every path you transmit 20 packets. They all get accumulated together at the receiver end, and after this all these 100 packets are reaching to the receiver by the 5 paths, then again rejoin the packets there at the receiver and streamline the data. Okay, so this is what is proposed by Zhao et al. They also consider load balancing as an optimization problem. The use of delay as considered by Zheng and al. As a criterion for load distribution may work well in case of real-time traffic where the nodes have pre-assigned slots to access the channel. However, in the case of best effort traffic, using delay as a criterion may lead to unexpected results because of the unbounded delay at time of high contention. So what they're saying is whenever many nodes are asking for a contention, in that case just using delay as a parameter might create some problem. So rather, if there is a multipath kind of a routing scheme, in that case divide the overall load equally or with some weight, okay, among all the different paths, and this is what is proposed by Zaved. So there are many algorithms proposed, only two algorithms in two papers by different authors we are discussing here. There's a last slide. What they're saying is load adaptive routing for throughput enhancement for load balancing. So two schemes we have checked in the previous slide. One is by delay, another is by dividing the overall load among all the multipath. Okay, so the last slide, the dynamic load balancing schemes considers the traffic load at every intermediate node in a path to make the routing or load balancing decisions. Okay, so every path, how much is the load carried out? Okay, that is checked to make the routing decisions. The traffic load and the nodes can be approximated by means of queue length of the nodes. Okay, so how much is the data queue, QUEUE, how much is the queue in the data in every node, that is checked. Okay, so number of packet transmitted in the channel within a time frame. So these are the parameters. The traffic load at the nodes can be approximated by means of a queue length at the nodes. Okay, so how much data is pending to be transmitted. Secondly, the number of packets transmitted in the channel within a time frame, and number of collisions experienced, or the number of traffic flow passing through the node. So all these are parameters which is deciding how busy a node is. So the traffic load at the nodes can be approximated by means of a queue length. So how many data are pending to be transmitted, number of packet transmitted by the channel within a time frame, that means how much is the data rate, number of collisions experienced. So if the number of packets to be transmitted is more through one point, definitely the number of collisions experienced will be more. And finally, number of traffic flow passing through the node. Okay, so all these are parameters through which we can find out whether a node or a link is overloaded. The load balancing and throughput enhancement schemes described in this section can function independent of parameter considered for traffic load measurement. So these are the four parameters actually by which we can measure whether any node or any link is burdened or overburdened, or if fairness of transmission is really happening or not. Some of the heuristic of dynamic load balancing and the traffic fairness among the mobile nodes proposed by Bhaya et al. Okay, so Bhaya et al. They are another group. Okay, they are also proposing a few things. Okay, so according to them, they have proposed some four algorithms. Just you know this. Okay, these are to be understood, not to be prepared for exams and all. So just understand this, what things are happening. So Bhaya et al. They have proposed four different algorithms. One is called as PHRS, preferred hybrid routing scheme. Second is base station supported reconfiguration. Third one is multiple exclusive shortest path routing. And number is multiple dispersion heuristics. So PHSR, BSR, MSPR, and MPD. So these are the four different routing schemes which are proposed by Bhaya et al. Et al means group, Bhaya and group. Okay, that is, these four routing schemes are for load adaptive routing for output enhancement and load balancing. So these heuristics are primarily based on the trade-off between the complexity of the computation, load balancing capacity, and the increase in the path length. Okay, so these were the topics. These were the three slides which were pending. I have completed it, and this finishes the first part of module 5. So next lecture we will start with the next generation techniques of hybrid